All right, this is section 4.4, complex and rational zeros of polynomials. We're actually going to skip section 4.3 and come back to it later on. But this week, we're really going to focus on solving equations that are larger than x squared. We're going to solve x to the thirds, x to the fourths, stuff like that. So when we go to find all solutions, we're going to try to factor. All right, if you can factor right off the bat, if you can see an easy factor, that's going to be the easiest way to do this. Now, this next step, step 2, where it says possible rational zeros, we're going to find all the factors of the constant versus all the factors of the leading coefficient. So this is going to give us a big list of possible answers. From those possible answers, we're going to pick a couple. We're going to use synthetic division, and we're looking for a remainder of 0. Remember, if the remainder is 0, that means it's a factor. All right, so once that's the case, then that number that we used is one of the solutions. We're going to use the coefficients below the line, and we're going to write a new polynomial. Now, we're going to keep doing this until we are left with a quadratic equation. Remember, quadratic's the easiest way to do this is to find or to use the quadratic formula. Now, one thing that's really important, and we'll talk about this again in section 4.3, but the number of solutions is equal to the degree of the polynomial. All right, the degree of the polynomial is the highest exponent. So when we start looking at questions, that's going to tell us how many x values we need. Here's our first example. The first thing that I want to look at is right here, is that 4. So that tells me that I need 4 answers at the end of this problem. Okay. Now, the next thing we're going to do is we're going to do what's called C over D. All right, so the C value is all of the factors of 8. Because over here, that's my C value, that's my D value. I'm not really sure why we picked these letters, and I get that it feels kind of backwards, but our factors of 8, we're going to go 1, 2, 4, and 8. Now you'll notice I put plus or minus because depending on what combination we have, you could do something like 1 times negative 8 or negative 2 times 4. So you just go ahead and put the plus or minus there. Then we're going to do our factors of 3. Plus or minus 1 and then plus or minus 3. Now our choices for C over D. Basically what I'm going to do is I'm just going to go through each C value and then put it over each D value. So 1 over 1 is just 1. 1 over 3 is 1/3. 2 over 1, 2 over 3. 4 over 1, 4 over 3. 8 over 1, and 8 over 3. So all I was doing was taking one of these values right here. Sorry, I'm trying to get it to highlight. One of these values right here, and then putting it over one of the values from the D value from the leading coefficient. All right, so over here on the right-hand list, we have 8 numbers, but because there are plus or minuses, we actually have 16 different rational answers. So there's a possibility that we could have 4 of these different numbers come up as answers. Now these are only rationals, so if we get square roots later on, you're going to notice that this does not really help. All right, so I'm going to go through and I'm going to change colors for my synthetic division. So unfortunately, this is just kind of a guess and check step here. Now, synthetic division is super fast, so that's why this is actually not that big of a deal. So I'm going to go through this pretty quick. And then right there, I'm going to actually stop. I'm not even going to worry about that because negative 8 and 23, I know that is not 0. So I know that 1 is not a factor. All right, now I'm going to try negative 1. All right, that's not going to be 0. Okay, so 1 and negative 1 don't work, so we're going to keep going. Now, your next step might be to try 2. I'm actually going to skip 2 because I know what the answer is, and I'm going to try negative 2. Now, I will try to guide you a little bit. I don't want you to just take forever to do these, but I also don't want to give you the answers. But if I feel like maybe you would get stuck on one, I will try to do my best to help you guys out. And there we go. 0 is a solution. So then I'm going to go ahead and circle that because remember, I need 4 answers. All right, so from my 4 answers, I've got 1 right there. X equals negative 2. That is 1 answer. Now here's the really cool thing. We're going to use our new coefficients. So now I'm only looking at 3x to the third plus 8x squared minus 2x minus 4. So hopefully I'm going to start being able to use a little bit fewer numbers. Let's go ahead and do negative 2/3. Again, I'm kind of cheating because I know what the answer is. And we'll do synthetic division real quick here. If you need to pause and kind of try the synthetic division on your own, it's not a bad idea. All right, and then that works also. So there's our second answer. So again, I'm looking for 4 answers. Right now I've got 2. And then we've got 3x squared plus 6x minus 6. All right, this is awesome because now I'm at a quadratic. I'm at 3x squared. And quadratics are super easy to solve. All right, so I'm going to go to my next slide just because I need a little bit more room. Again, I'm looking for 4 solutions. Already, I know that x equals negative 2 from synthetic division, negative 2/3 from synthetic division, and I had the quadratic 3x squared plus 6x minus 6. That's going to give me my other 2 answers. All right, now, looking at this problem, I do notice that I could factor out a 3, so I'm going to maybe see if that helps me out a little bit. And then, okay, unfortunately, it doesn't look, yeah, I can't factor that one anymore. So I'm just going to have to do quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you might get imaginaries on that. That is okay. We've never said that we can't have imaginaries. Let's see, now I need to break down the square root of 12 because 4 times 3, that's going to give us 12. 4 is a perfect square. So remember, he goes through those magical doors and he gets square rooted. Now, remember when you have one number on the denominator, you can split it up. So negative 2 over 2. And that's going to give me negative 1 right there. Those 2's divide out and square root of 3. All right, so then I've got 4 total answers. All right, now you can write those last 2 as plus or minus, but again, I wrote it out on this one just so you guys could really see. Here's one answer, here's the second answer, here's the third answer, here's the fourth answer. All right, make sure you can sort of check your work on these. You should not turn anything in until you have 4 answers because we knew this was something to the 4th power. You know you've got to have 4 answers. All right, let's try a couple other examples. Again, here's my C value. Again, factors of 8. So 1, 2, 4, and 8. Factors of D. This one's nice. It's just 1. Okay, so my possible choices are 1, 2, 4, and 8, and then obviously plus or minus for each of those. Let's try synthetic division. Let's start with 1. There's no rhyme or reason to starting with 1. That's usually just what I do. All right, I can see right there that's not going to work. So 1's not going to work. Let's try negative 1. There we go. Negative 1 works. Negative 1's an answer. Remember, I'm looking for 3 answers, so I've got 1 out of my 3 answers. I'm just going to kind of keep a little list up here. X equals -1. I got to get 3 numbers in that list. Now here's the cool part. Remember I had x to the third. I'm going to drop down an exponent, so I'm going to go x squared minus 2x minus 8. Now we could, again, oh, now I notice this is a quadratic. All right, so I don't necessarily want to do synthetic division anymore. I want to either factor or use quadratic formula, something like this. And this one, I think, let's see, this one actually factors, doesn't it? Yeah. All right, so again, if you can factor, that's going to be the easiest way to do this. So set both of these equal to 0. And there is our other 2 answers. All right, perfect. All right, so now, sorry, there should be positive 4 right there. Now, one thing that's kind of cool to look at, you know, we knew -1. We sort of picked that from our list, but then we got an answer of 4. All right, there's 4 in that list. And then we had an answer of -2. There's -2 in that list. So remember on our last example, we didn't necessarily see our answers in that first list because they were not rationals. This one, they were rationals, and we were able to figure it out. All right, our last example. C values 1 and 3, D values 1 and 2. So my possible choices are 1, 1/2, 3, and 3/2, sorry. All right, we just go through and we're going to do our synthetic division. Let's see, I'll start out with 1. If you guys want to, why don't you pause this and see if maybe you can try this on your own, and then unpause it. If this works or doesn't work, unpause it, watch the rest, and see if we get the same answers. All right, so that is an answer. Again, I'm looking for 4 answers. My first answer is 1. Okay, let's try to write some smaller polynomials. So there you go. Now we're going to have less synthetic division. Let's see. Let's go to 3. I would definitely stay away from fractions if you can, but this one, we could have tried -1. I'm going to skip -1 just for the time being, and if we need to, we'll come back to it. And that's why I skipped it, because I knew this was going to work. And now drop down our exponent a little bit. Remember, this was a 3, drop it down. So I'm going to go 2x squared minus x minus 1. All right, there's a quadratic. So quadratic formula or factor. Let's just guess and check real quick. These are small numbers. So this has got to be 2x and x. Let's see, the only way to multiply to 1 is 1. And then I know if these are opposite signs, that's how we would multiply. So let's see, check our O and our I. 2x times 1, that's -x. 1 times x is positive. Yeah, that actually works there, doesn't it? All right. So you don't always have to use quadratic formula. If we can factor, that's going to be the easiest thing to do, but that does not always work. And again, before we turn anything in, you might as well, you need to know that you've got the right number. So I've got 4 answers circled, so I know I'm probably on the right track. My 4 solutions are 1, 3, -1/2, right? That showed up on the list. And then, oh, this is kind of interesting. We get 1 twice. All right, so really, in terms of my final answer, I'm probably not going to write that 1 both times. Now, I understand that this kind of looks like it has only 3 answers, but if you remember back to graphing, this is going to be a multiplicity of 1, a multiplicity of 2, and that's sometimes called a double root. Remember these multiplicity of 2, that's where we were going to touch but don't cross the graph, and that's the exact reason that it shows up. So in terms of touching the graph, it's because really you sort of like touched it and crossed it at the exact same time because you had 2 of those numbers that show up. So I'm okay if you write it twice, all right? If you put 1, 3, -1, and then 1 again, I'm okay with that. Just know that going forward, most of the time, when you see answer keys and stuff, if something has a multiplicity of 2, sometimes we'll write that out in part of the problem, but very rarely are we going to go ahead and write it out twice. More than likely, we're going to write 1 with a multiplicity of 2, and that's how you show that you've got that double root there. So that is the end of what we're going to do from this section. Anything in the notes that we skipped over, we will come back and work through in section 4.3. So that is the end of section 4.4, complex and rational zeros of polynomials.